Hello and welcome to this video. So today we are going to do some mathematics. In particular, we are going to calculate some probabilities on this chessboard. It's also a checkerboard, by the way. It's the same board both for chess and checkers. So the question is, we have a standard 8x8 checkers board, okay, or 8x8 chessboard. It's the same board. And we have 12 brown pieces. There are 12 of them, you can count them. And also you have 12 cream pieces. If you want, you can call them white pieces. But yeah, we have 12 brown pieces and 12 cream pieces. And that's the starting position, okay? This is really a standard chessboard, and this is the configuration. So what happens is that we are going to move a brown piece, okay? Just any movement. It could be this, okay? It could be this, whatsoever. And we are also going to move a cream piece. So we are going to make a move of each piece type. Let's say a move here and a move here, okay? Hope you can clearly see that. It's true that there is some reflection from the sunlight, but I hope you can see that clearly. So we move each piece, okay, following the standard movements rules for checkers. And the question is, what is the probability that after these moves, the brown piece and the cream piece are going to be on the same diagonal? For example, if you have this piece that moves, let's say the brown moves here and the cream pieces move here, you see that they are on the same diagonal, right? So the question then here is, what is the probability that after a move of each piece type, a move of the brown piece and a move of the cream piece, that we are going to have the two moved pieces on the same diagonal, okay? Like here, for example. And that's the probability that we are going to try to calculate. Actually, I just came up with this problem randomly, and I thought it would be cool to be able to calculate that. Okay, you will tell me your opinions in the comments. So I'm going to present you my solution, okay, to this problem, and feel free to comment or add your remarks in the comments, or also how you have gone about solving this problem. If you prefer, you can pause the video now, okay, and go and solve this problem before coming to watch my solution. So it's a solution I came up with. It's totally independent, okay, and it's just the way I thought we could solve this problem, and you're going to tell me your remarks about this. Okay, so the first thing to do here, this is the way I went about solving this, is to first calculate the total number of possible moves, okay, of each of the pieces. For example, if you take the brown pieces, what is the total number of possible moves? And this is actually straightforward, because let's take this piece, for example. You see that it can move like this, okay, or like this, okay. This one can move like this and like that. So actually, for each set of pieces, there are actually 7 moves that each one can do. And if you want, let's count them together. You have 1, you have 2, you have 1, you have 2, that makes 4, you have 5, you have 6, and you have 7. So there are 7 possible moves that the brown piece can make, and also there are 7 possible moves that the cream pieces can make, which means we have a total of 7 independent moves that each one can make. So let me take my sheet of paper. So we're going to say the total moves in the first place is equals to 7 for the brown pieces, okay, and 7 for the cream pieces. And since those 7 moves are independent, we got to multiply them and that gives us 49 moves in total that are possible for each set. Okay, so there are 49 possible moves or 49 possible configurations that we can have after moving a piece of each type. Are you okay? Then the next thing we want to do here is to try to find out how many of these 49 moves or these 49 configurations correspond to a situation where the pieces are on the same diagonal. For example, suppose the brown started by moving this piece like that, then the cream moved here. You see that they are on the same diagonal, right? Or suppose that the brown instead moved here. You see that we are also on the same diagonal. So how many of those 49 moves correspond to a situation where the moved pieces are on the same diagonal? That's what we are going to calculate now. And to do this, let me take back my paper. So to do this, let me take another pen. So let's take one set of pieces. So if you look at this chessboard, okay, let's look at the position of the first row, of the front row for each set. So if we take these ones, we have 4 pieces here, and we also have 4 slots, 4 possible slots where these 4 pieces can move. So I'll try to represent them here. So we have 4 slots. We have, let's see, 1, 2, 3, and 4. Okay, corresponding to these 4 slots. And then we have 4 pieces, okay, that are just shifted diagonally backwards. So I'll represent that with another color. So we have the pieces are like this: 1, 2, 3, 4. Okay, so here let's assume we have the cream pieces. All right, so additionally I'll just add the slots for the brown. Okay, so I'll do this, 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 and this. Okay, and obviously you also have the brown pieces, but I won't add them. So what we are going to do here is that we are going to count the number of possibilities of obtaining a diagonal if a piece is found in each of these slots. So let's say the cream, because these are the front slots, okay? So if the person playing the cream pieces decided to move a piece in each of these slots, how many configurations would it be possible to obtain so that we get a diagonal? That's what we're going to try to figure out. Let me take back the chessboard. So if you look carefully here, it's a bit messy here. Let me shift that. So if you look carefully here, let's take this slot, okay? This slot height right here. Suppose that I play and I move this guy over here. If I want to get a diagonal, then the person playing the brown pieces must play either here, that's one possibility, here, that's 2, or here, that's 3. So that makes 3 possibilities if if the cream piece plays at this position, then the brown would have 3 possible moves in order to have the 2 pieces on the same diagonal. Same goes for whether I had played here. If I had played here, then the brown piece would have moved here for me to get a diagonal. That's 1 move, or here, that's 2, or here, that's 3. So we can conclude that if a move is played at this position, if I play at this location any piece, any of these 2 pieces, then there would be 3 possible moves that the brown could make so that we are on the same diagonal. So I'll take back this paper. So I'm going to put a 3 in the square, which means that any piece that is here, whether it's this one that is played here or this one, there will only be 3 configurations that the brown could play so that we are on the same diagonal. So we are going to do the same and count the number of possibilities for this square, and for this square. So let's suppose I played a piece on this square. So let's say I pushed this one here or this one here. How many configurations would it be possible for the brown to play in such a way that we are along the same diagonal? So let's come back and count that. So here we have the second position. So if I play it, for example, this, let's count the number of configurations. This one can come here, that's 1. Or this one can come here, that's 2. We're on the same diagonal. Or this one can come here, that's 3. We're on the same diagonal. Or this one can come here, we have 4. That's the same diagonal. And same goes whether I had instead pushed this one here, which means that at this square, there are 4 possibilities to have both pieces on the same diagonal. So we are going to write a 4 over here. Hope you can see that. And similarly, if this piece is played here or here, we can realize that the square will also have 4 possible configurations of obtaining a diagonal. Okay? Now, for the last square, there is only one possibility if this guy is played here. In that case, if I play here, that's the last possibility, then can you guess how many ways the brown can play in such a way that we get a diagonal? Yes, it is only 2 ways. It's either the brown plays here or he plays here. Those are the only 2 possibilities for us to have a diagonal if a piece is at this last box, which means that for that last box, we are going to put a 2. Okay? Then what we are left to do is now to count the total possibilities for obtaining these diagonals, and that will give us the total number of configurations in which we can have diagonals. So I'm going to say here that diagonal moves is equal to, so let's start with this first piece. This first piece only has 1 possibility. It can only be played at this location. Okay, if I take this piece can only be moved here. That's the only possibility. And if it's moved here, then there will be 3 ways that the brown could play for us to have a diagonal, which means for the first move, we have 3. Okay? Then we add to the second piece. So if this piece here, if you take this piece, it can move either here or here. If this piece moves here, there will be 3 possibilities of obtaining a diagonal. But if it rather moves here, there will be 4 possibilities. So that makes 7 possibilities in total for this second piece. We do the same for the third. This one has 2 possibilities. If it's played here, we have 4. And if it's played here, we also have 4. So that makes 4 plus 4, a total of 8 for this piece. And for this last piece, if it moves here, we have 4 possibilities. And if it's moved here, we have 2 possibilities. So this is for this one, this is for this one, this is for this one, and this is for that. So summing all that, we are going to have that 3 plus 7 plus 8 plus 6. That gives in total 10, 18, 24. So that gives a total of 24 configurations out of the 49 in which we have a diagonal. So the probability then the probability in this case is just going to be equal to 24, the number of configurations in which we have a diagonal, divided by 49, the total number of configurations. And this is the result. Okay, so I would like to know if, tell me in the comments if you obtained the same result that I just obtained. If so, then tell me if you used the same method as I did, or another method. I'll be glad to know how you went about solving this problem, and hope you find this problem overall interesting. And let me know also in the comments whether you would like to have more of such problems in future, because I thought of other interesting problems we could have for the chess board or for the checkers board. So until then, stay safe, and I see you in the next video.